Okay, we're going to tackle 3 more homework problems together. How about 33? We're supposed to show that this equation is true. So let's start with the left-hand side. We will copy it and paste it over here, and we're going to try and end up at the right-hand side. This requires that you know 2 of the log properties. There are 3 basic log properties that you have to know. If you're rusty on log properties, I suggest you Google log properties, and there are 3 of them. We'll actually chat out 2 of them right here. So what should we do? First, try to align our lines. How about that? So this equals, the first summand has a 1 in for k, so 1 log 5. Stretch out my box slightly. Plus 2 log 5 plus 3 log 5 plus 4 log 5. Now you recognize that log 5 is a number. This is 10 to 1 power equals 5. So this is going to be some irrational number, you know. I don't know what it would be, 0.426 or something. That's what log 5 is. So this is 1.426, 2 times 0.426, whatever. The important thing, though, is if I have 1 of them, and I have 2 more of them, and I have 3 more of them, and I have 4 more of them, then I have a total of, let's see, 1 plus 2 is 3 of these log 5 buggers, plus 3 more is 6, plus 4 more is 10 of those log 5 things. Now, I guess that's not really a log property, so we're really only going to use 1 log property here. We'll use another log property down here. So what's happening here is we have to take the multiple out in front, and the log property says if you have a multiple out in front, that is the same as having an exponent on your log. So that's what we're looking for the answer. That's using the log property of exponents. Okay, on 34, let me move this slightly to the right so we've got just a little more room. Here, what I decided to start out by leaving the outside alone and trying to figure out what on earth j equals 1 to k of 1s are. So first thing we're going to do is we're going to plug in j equals 1 into this equation. Oh, there aren't any j's. Well, what's that mean? That's like a constant function. If you have a constant function and you try to plug something in, your output is just 1. So this summand, this inside piece, turns out to be 1 plus, well, the second term you get out of the summand, 1 plus 1 plus 1 plus 1 plus 1. Right? Oops. That was not what I wanted to do. So, the upshot is we get 1 plus dot 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 plus 1. Okay, that's what goes inside there. How many 1s do I have? Well, I have k of them, exactly k of them. So, what that means is that this is equal to another sum, and this is equal to the sum of k, right? That inside piece is equal to exactly k, so I'm doing this summand. So then I'm adding the numbers k from 1 to 6. That's actually an arithmetic sequence, if you remember, 1, 2, 3, 4, 5, 6. Now it's simple enough that if you want to, you could just add them up. So we could add up plus 2 plus 3 plus 4 plus 5 plus 6, or we could use the arithmetic sequence, the arithmetic sum formula. We'll do the latter just for good practice. So let's see what happens here. Remember that the formula is equal to, now we've got to get the number of terms. How many terms are there? There are 6 terms times the first term, which is 1, plus the last term, which is 6. and we're going to have to divide that by 2, right? So I will jerry-rig it so it looks like that. Now 6 over 2 is 3, so 3 times 7 is 21. And you can verify that that happens the old-fashioned way too. Okay, so the last problem, how do we break this piece apart? Well, the property of addition with logarithms says that if two things are multiplied on the inside of a logarithm, that's the same as adding them on the outside. So that breaks apart as log 1 plus log 2 plus log 3 plus log 4 plus log 5 plus log 6. Okay? Now, notice that this is exactly the sort of thing that people would want to use sigma notation for. We have 6 of these. I'm going to want to write each of my sum ends. But instead of writing log 1, 2, 3, 5, 6, let's just write log of. So we'll put in a sum there, and then I'll write log of, let's say, k, and we'll count k from 1 to 6. And since I have that exactly over here, I will go ahead and cannibalize, and there you have it. Woohoo! We're done.